So this is 8.2 solving systems of equations algebraically. Solving a system of equations in two variables algebraically means determining values of any ordered pairs that satisfy both equations in the system. You can either solve by substitution or by elimination. That should be a good reminder from Foundations 10 or Foundations 20. Make sure that you have these steps memorized. You can always reference them during the assignment though. And the first thing that we're going to do is we're going to jump right into an example. So solving a linear quadratic, first thing that I need to point out is I wrote down a number wrong. This should be 10. So then we have, let's see here, y. So we're going to add y over, add y here, subtract 10 here. So y is equal to 5x minus 10. And then we have x squared plus x minus 2y is equal to 0. So here's what I would do, is we would sub this into here, because we could solve it by elimination, but then we're dealing with quadratics. I find it's easier to do solving by substitution for this. So let's do that. So this is x squared plus x minus 2 multiplied by 5x minus 10 is equal to 0. So then we get x squared plus x minus 10x plus 20 is equal to 0. So then that leaves us with x squared minus 9x plus 20 is equal to 0. Factor this. This is x minus 4, x minus 5 equals 0. So then we have x is equal to 4 and x is equal to 5. So now that we have the solutions to the quadratic, what we should do is we should take these, sub them into the linear because it's easier to find the y value. And if I sub x is equal to 4 into this equation, let's just think about that for a second. What's going to happen here? Well, it should create a 0, right? If we know what we're doing. That's why we don't usually sub into the quadratic after finding a quadratic. So if we look at this, this is y is equal to 5. We'll do the 4 one first, minus 10, which is 20 minus 10. So then we get a value of 10, and then we do y is equal to 5 multiplied by 5 minus 10 is equal to 25 minus 10 and 15. So our two solutions are 4, 10 and 5, 15. So let's go on to solving a quadratic. You may use either substitution method or an elimination method. You must determine the solution to the quadratic equation. When solving this type of system using elimination, you must eliminate y. So then let's rewrite this. Ooh, I made another mistake here. This should be a plus sign. So 3x squared minus x minus 2 is equal to y. And 6x squared plus 4x minus 4 is equal to y. So then I'm going to stack this guy on top, and I'm going to subtract. I'm going to subtract because these are both positive, and that'll get rid of it. So 3x squared minus x minus 2 is equal to y. Crosses here. Then this becomes 3x squared, 4x plus an x gives us plus 5x, negative 4 plus 2 gives us negative 2 is equal to 0. Perfect. Now what we can do is we can factor this. It is not an easy trinomial, so this means we need two numbers that multiply to negative 6, but add to positive 5, that'll give us negative 6, no, positive 6 and negative 1. So then this guy breaks down. get 6x minus 1, x, negative 2, 3x squared plus 6. Draw your line. Greatest common factor here is 3x, and this is negative 1, so this leaves us with x plus 2, x plus 2. So this factored gives us 3x minus 1 multiplied by x plus 2 equals 0. So x equals 1/3, or x equals negative 2. We plug that in and we check. So we go 3 multiplied by 1/3 squared minus 1/3 minus 2 equals y. So this is 3/1/9 minus 1/3 minus 2 equals y. Cancel here. That gives us 1/3 minus 1/3 minus 2 equals y. So then we get 1/3 comma negative 2. And when you sub in the second one, because I ran out of room, you should get negative 2 comma 12. And those are our two solutions. So that's it for this chapter. Finish up this assignment, go on to the review and the practice test, and you're good to go.